IPv4 addressing. In the first section of this video, I'm going to talk about IPv4 addressing. I know that you have learned about the IPv4 addressing in CCNA, but now I am going to talk about some of the, for example, concepts about the IPv4 addressing and also some tips about the IP addressing troubleshooting. Don't forget that the requirement of this part of this video is the IP addressing part of the CCNA class. In this video, I'm not going to talk about the detail of IPv4 address. Only I'm going to review some of the topic related to the IPv4 addressing. Here we have a simple scenario. In this simple scenario, I am going to talk about the IPv4 addressing. Look at here. Here we have PC1 and PC2. These two PC are connecting to the one switch, and after that here we have one router. This is our first network. Also here we have another network, one PC, PC3 connected to the switch, and finally to the router. I'm going first to review the process of the sending traffic inside of the network and also outside of the network. Assume that in PC1, okay, we are we want to send traffic from PC1 to PC2. Each traffic can be sent and the traffic type is not important. For example, in PC1, we are using this command ping then 10.1.1.20. What is happening? Okay, I'm going to review the process. The first thing that is happening is the routing. Okay, you know that in PC1, first the PC1 should find that the destination IP is residing in the network of itself, or the destination IP is residing in the outside of the network of PC1. How PC1 can find the destination IP is residing in the network of the PC1 and or maybe is residing in the outside of these networks? You know that this is so important. Why? Because if the destination IP is residing in the same network of the PC1 can directly send traffic to the PC2. But if the destination IP is residing outside of the network of PC1, the PC1 should send the traffic to the default gateway. Let me write here. You know that when the PC1 understands that the destination is residing in the same network, okay, it can send directly traffic to the PC2, okay, the destination, for example. But if the destination IP is residing in another network, okay, for example, in other networks, we can send the traffic to the default gateway. Because of this is an important decision that we should make on the PC1. Okay, here we can use another, for example, network, and then we can send the traffic to the default gateway to the router 1 in this scenario. Okay, how the PC1 can find the destination is residing in the network of PC1 or is residing in the other networks and other networks. Okay, you know that the PC1 should compare its network ID. Its network ID means the network ID of its IP address with the destination IP address. Look at here. You know that here the IP address of the PC1 is 10.1.1.10/26, means 26 of the 26 first bits of the IP of PC1 is the subnet part. Let me to review here for you. Here, you know that in one IP address has two parts. The first part is the network, or maybe you call it subnet, and the second part is the host part. Okay, and we can use the subnet mask, or for example /1 then a number CIDR notation for finding the network and subnet part of one IP address and also host part. For example, in PC1, if we want to find that the network ID and also the host ID of the PC1, we can use this formula. Let me to convert the IP address to the for example binary. You know that here we have 10.1.1 for example 10, and the subnet mask is 255.255.255.192. Why? Because that /26 means 255, 255, 255, then 192. Okay, this is a subnet mask. Let me to show you here. Now, we know that the first three parts, the first three octets are the network parts. We don't need to convert them to the binary, but about the last octet, the fourth octet, we can convert to the binary. Look at here. 192 is equal to the 1 then 0 0 0 0 0 0. That's it. And also 10 equal to the 0 0 0 0 then 1 0 1 0. That's it. Okay, let me to find the network at the network ID in the IP address. As you know here, the first two bits of the fourth octet are the network's bits. Because of that, we can understand that then these two bits are the network bits, and this means that the first two bits of the last octet are for example, network bits. And finally, we can understand that the 10110/26 is the network ID of the IP address of the, for example, PC1, okay, or network address. We call it network address or network ID. Both of them are same. Okay, now we should compare the first 26 bits of the PC1 with the first 26 bits of the PC2 to understand that the PC2 is residing in the network of the PC1 or is not residing in the network of PC1. Okay, let me to compare here. We can convert the 101110 and 101120 to the binary. Let me to show you here the 10 first PC1 IP address 101110. If you convert this IP address to the binary, the result is quad 0 10 0 10 0 dot, after that 1 quad 0, then for example 0 0 0 1, again dot, again quad 0, again 0 0 0, for example 1, and finally quad 0 10 10. This is the 101110. Okay, let me to show you 101120. Okay, again about the first three octets we don't have any change. Because of that, let me to write it again here and then here, octet 2 and then octet 3. Okay, and finally in the octet 4 we have again 0 0, and after that 0 then 1, after that 0 then 1. Okay, 0 0. As you can see, this is equal to 2016 plus 4. Now we can compare the first 26 bits with each other. Here, as you can see, the first 26 bits can reach to this for example bit, and as you can see, both of them are same. We can say that here we have the same for example value, here we have the same or equal value, and also here we have the same or equal value in the first two bits of the fourth octet. Again we have the same value. Because of that, we can understand that these two IP addresses are residing in same network. So easy. And after that, the PC1 after for example sending the ARP request and receiving the MAC of the PC2 can send directly to PC2 without the usage of the, for example, default gateway. This is the routing in the PC. You know that we call it routing. Routing can occur in PC in router. Okay, in PC the routing means that destination IP address is residing in our network or in another network. But assume that we want to send traffic to the PC3. Okay, again we should do the same function. For example, here the IP address of the PC1 is 101110, as you can see here, and also the IP address of the PC3 is 192.0.0.0 for example 210, and it is obvious that the first 26 bits of these two IP address is not same. Let me to write you, but it is obvious. Look at here, 11 again 60, then dot, again 80, again for example dot, and after that 0 0 0 0 1 0, and finally 10 quad 0, and then 10 10. Okay, if you compare these two parts to each other, you can see that here we don't have any any, for example, equal values. Because of that, we can understand the PC tree is residing in